Alright guys, what video is this? Video 3, 6th grade. If I sound confused, it's because I'm making multiple videos this whole week you guys have off for my other classes. So we talked about ratio yesterday, which compares two quantities with division, but I'm just going to stop with two quantities. And you guys saw a lot of stuff like this. For every 2 cats, there might have been 10 dogs. Alright? And so, similar cast of dogs, rate gets a little different. Rate is going to compares two quantities of different units. What on earth does that mean? Well, let me show you. See, dogs and cats are different, but they're two pets. But here's what they mean. Watch what I'm going to do. We're going to measure how long it takes me to drink. I think this is 16 ounces. Right? So we're going to talk about liquid ounces. So here we go. We're going to talk about ounces. And we're going to compare it to time. Do you see how one is weight, capacity, and one is time? Those aren't similar units at all. They're very different. And this is where rate comes in. It's a ratio, but it's a more specific type of ratio. So watch. So let's time this. How long will it take me to drink this? Let's see. Ready? Start. That's hard. Almost there. Oh, that almost killed me. So, in 15 seconds, can you see that? 15 seconds, I drank 45 ounces of water. That's what I did. Now this is what's unique about this. If I just said I drank 45 ounces of water, okay, that's nice, Mr. Todd. My turtle can, my dog can. How long did it take you? Was it hard? Was it easy? There's just very little information there. But the moment I compare it to something else, this is where rates get helpful. Suddenly I realize, well, hey, no, my turtle really couldn't do that. Neither could my infant baby. And suddenly you realize, hey, that's pretty slow because I can do it in 7 seconds. And you begin to be able to, it's called quantifying, you can kind of measure it more precisely. And so this is one way rate is very, very helpful. And it's different than ratio because this is very distinct to units. In fact, let's do another one. Ready? I'm going to see how many times I can blink my eyes. Can you see my eyeballs? Yeah. All right, in 10 seconds. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61. Was that 82? I think it was 82. So, look at that, 11 seconds. Actually, it's almost 12. You see, it's 0.55. So we're going to, time, in 12 seconds, I was able to blink my eyes. How many times was it? Let's just say 84. And I was able to blink. Do my eyes blinking have anything to do with time? No, they're two different units. And so that is why it becomes rate. It is a ratio, but a specific type of rate. And it's because I'm comparing two quantities of different units. I forgot quantity, sorry. So why is Mr. Todd acting so weird? Well, first of all, that's how I act. But secondly, it's because I'm trying to make a point here, is that rate is a ratio comparing two different types of units. That takes us into another vocabulary word, unit rate. Unit rate. And here we kind of get into vocabulary wars because unit refers to the things you're measuring. It also can mean one. And so let's read the definition of unit rate. A unit rate has a denominator of 1 when the rate is written as a fraction. So it's a rate with the denominator of 1. Now, how does that play into this? Well, here's what's kind of neat about this. I understand that in 15 seconds I can drink 45 ounces. But what if I said, Mr. Toth, how much can you drink in 20 seconds? So I'll write that over here. In 20 seconds. So I want to answer this by the end of today. Well, unit rate helps us do that. Unit rate says we want to get this down to, with a denominator of 1, which means for every second, I'm going to write second, I will know exactly how many ounces I can drink. So if you start, I mean, you can think of this as a fraction, because a ratio is a fraction. And so let's give us a little bit more room here. What do I have to multiply this by to get, or excuse me, divide it by to get it down to 1? Well, 15. See that? And so when I divide the bottom by, I divide the top by, which is the same as 1, or I mess up my proportionality. 15 divided by 15 is 1, 45 divided by 15 is 3. And now let's read this ratio, because this isn't just 3 over 1, it is I can drink 3 ounces in 1 second. Do you see how this works? It allows us now to be more precise. Look at this one. What if I want to know how many blinks I did in 1 second? Well, all right. What do I have to do 12 to get it down to 1? I have to divide it by 12. So therefore I divide the top, because that makes it that I'm dividing by 1. 12 divided by 12 is 1. 84 divided by 12 is 7. And what does that mean? For every second, I can blink 7 times. And that's what that means. Why is that helpful? Because if I can get it down to 1, then I can get it to any time I want. So if I know for 1 second, well, that's a cinch. Well, then, Mr. Toth, just multiply it by 20 over 20 to get it to 20 seconds. And now I know that I can, if I was able to go at the same rate, I could do 60 ounces in 20 seconds. That's how this is helpful. If Mr. Toth was nuts and he wanted to know how long it would take to do it in 1 minute or 60 seconds, I could multiply both by 60, because I'm at 1. 1 times 60 is 60. 7 times 60 is 420 blinks per second. But what I want you to remember right now is unit rate is rate with a denominator of 1. See my denominator? It's 1. So let's take a look at a few examples. So if you should pause this and take notes. Let's take a few examples. Here's one. Here is, I wish I could do this. In 18, I can run 18 miles in 30 seconds. Is that right? 18 miles. I don't like that one. Let's do it this way. Let's do 180 miles in 30. If I could speak English. I can drive 180 miles in 30 minutes. Okay? I want to get it down to unit rate. Well, if you can't see really quickly how to divide it, then you can always come over to the side. So if I know if I divide the bottom by 30, I'm going to get 1. So now divide the top. 180 divided by 30. Whoa, be neat. Would be 60. And so I divide the new denominator by 30 and the numerator, and I'm able to get down to the unit rate of, I can do 60 miles in 1 minute. And that's pretty doggone fast. That's pretty fast. That is how you could get it down to unit rate. What if, let's try another one. I am pausing to think. I can eat, an orangutan can eat 45 oranges in 9 minutes. So here is oranges, that looks like doctor, here is minutes. If I want to get it down to 1 minute, all right, we'll divide that by 9, divide the top by 9, right? Obviously, divide by itself, it goes to 1. And now I'm down to, I can eat 5 oranges in 1 minute. Sometimes they get a little bit, they won't be able to be expressed with a 1. I guess they can. That's kind of why I kind of paused with how they're teaching this, but that's okay. Let's see it. Yeah, well, I guess that's not asking for unit rate. So let's turn the page. Let's take a look at 34. Number 1 is 44 points and 4 quarters. Number 2 is 125 feet in 5 seconds. Number 3 is 320 miles in 12 gallons. And number 4 is 12 meters in 28 seconds. So let's go for this. Let's go for it. All right, well here, if I want to get this down to 1, I'm going to divide by 4 over 4, and I'm going to get 11 in 1 minute. I think that's what it was, right? No, it was 11 points in 1 quarter. Look at this one. I want to get this down to 1, so I'm going to divide by 5. So that gives me down to 1. Well, that would be 25. And for number 2, I have 25 feet in 1 second. Look at this one. 360 miles for 12 gallons of gas. Well, if I want to get that down to 1, I'll divide it by 12. So that gives me 30 miles traveled with 1 gallon. But look at this last one. This one's interesting. Here, as you can see, all of these situations, there is more in the numerator than the denominator, so it divides out. But here, oh my goodness, what's going to happen? So what's interesting is they're suggesting you simplify it as much as possible. So let's simplify it by 4 over 4. And what we would get is 3/7, which would mean the most simplest form of that would be 3 meters in 7 seconds. Now that's how they're suggesting it. I think that's this. You could take it further, but if I go any further, I start getting into parts. Because look, if I follow what I did up here and divide it by 7, look what happens. That's 1, and then I have 3 divided by 7, and I start getting into decimals, which there's really nothing wrong with that. That's approximately 0.42 over 1, or you could say 3/7. So I guess we won't get the decimal. So we'll express this as 3/7. So what does that say? You can do 3/7 of a meter in 1 second. So they're actually, that's it. They're asking you to express it as a fraction. Let's try another one like that. That's kind of interesting how that works out. So let's take a look at number, all right, let's take 18, let's try this one. 18 minutes, nope, 18 miles in 30 minutes. So here's miles to minutes. Now you can see the denominator is greater. And because it's greater, it's not going to go down to a very clean answer. So, but watch. Let's simplify it by 6 over 6, and I get 3/5. So I can do 3 miles in 5 minutes, or I could think of it as 3/5 of a mile in 1 minute. Whoops. You see what I did? I turn this in to my numerator and make that my answer over 1. Okay, because 5 isn't going to divide evenly, so but we can express it in over 1. It becomes a complex fraction. Let's see. I just ripped through page. What page was that? That was page 34. Do I have time? No, I'm out of time. So, guys, here's what you want to remember. Ratios we studied yesterday compares 2 quantities. Rate, we start getting into, you're comparing 2 very different things. Very common one is miles per hour. All right? Distance and time, 2 different units. And then there's very specific unit rate where 1 is in the denominator place. Guys, take your time, correct your work.